Okay guys, so last time, in the last video, I talked about significant figures and what they are and how we use them and how we figure out how they relate to uncertainty and how we figure out how many significant figures we have. And I even talked about how we figure out how many significant figures are we record in a measurement. Now I'm going to talk about I'm going to talk about the calculations, how we use them in calculations. And this is really the why. This is why we have talked about significant figures in the first place, because it helps us figure out how to accurately display how precisely we know a number. So a little example I'm going to give you, poorly drawn in paint, as all of my examples have been. So here I am standing next to this truck. This is a truck, my fictional truck that I don't actually own, and I'm going to go pick up some apparently floating magenta cargo and cross this bridge with no railings. So I, for some reason, am so nitpicky that I know exactly how much weight the bridge can hold down to the nearest pound. Okay, this is clearly not a real-life situation. Obviously, we're not really in a situation where if I go 1 pound over the bridge, this is going to fall under its own weight. However, I know that the bridge can hold this mass, and anything over that to the nearest pound, anything over that, it will collapse. I know I have meticulously weighed my truck, including the gas, myself, and the calculator I apparently keep in the glove box, also to the nearest pound. I pick up the cargo, and I ask the person who gives me the cargo, I say, how much does this cargo weigh? And they say, 4,100. And I ask very intently, how well do you know that? How precisely do you know that? And they say, well, to the nearest 100. So, as we talked about before, this measurement is now recorded this way. 4,100 pounds plus or minus 100 pounds. These two zeros, no decimal point, they are not significant. So my other two measurements are to the nearest pound. This one is to the nearest 100. So I get out the calculator I keep in my glove box and I do my math. And I find that the total mass of everything together is 8,362 pounds, which is under the mass that the bridge can hold without collapsing spontaneously. So the question is, can the driver safely cross the bridge? So think on this for a moment, pause it if you need to, and come up with the answer. The answer is no. And this is because I have not really represented this measurement correctly. This measurement, I don't really know that the truck and the cargo and everything is 8,362 pounds. Because there is a 100-pound who knows sitting in this measurement over here. So what I have to really say is it's 8,400 pounds, give or take 100. That might put it over. It might be under. I don't know. Odds are, I guess, kind of good, but we don't really know. And this is the point. These rules I'm about to show you help us to accurately portray how well we know a number and not to pretend that we know a number more precisely than we really do. So let's talk about how these rules actually work in real calculations. So when we talk about the rules, the whole point of the rules is to not increase or decrease the uncertainty of the measured values, to accurately represent what we know and what we don't know. And to this end, there's two rules. Now this can be kind of tricky. You've got to keep separated in your head that there's different rules. And the problem is in this class, we're mostly going to do, for the first part of this class, it's going to be nothing but multiplication and division. And so you'll get really used to one rule and forget about the other one. So right now in your head, make a division. There's a multiplication division rule and then an addition subtraction rule. We'll talk about the multiplication division rule first. It's pretty easy. It's easy to explain. Multiplication division is simply when I multiply or divide, and actually I can do, and it doesn't matter how many operations I do at once, so I'm just going to start with a simple one. But what I do is I look at how many significant figures each of the values being multiplied or divided has, and I find the one with the fewest significant figures. And that one dictates how many significant figures are in the final answer. So here's an example. So I've got 6.38 times 2.0, equals 12.76. This is what I get out of the calculator. So this is my calculator answer. Your calculator doesn't understand significant figures. Your calculator doesn't know how to round. So we're going to have to round this off. So if you look, this one has 3 significant figures. This one has 2 significant figures. So our final answer should have not 3, I did that incorrectly, should have 2 being the fewest. This number has 2. So we have 2 significant figures, which means we're going to, starting from the left, we'll round off after the 2. So we round to 13. So that's the number we get. And we'll do some more practice on this in a minute, but just getting through explaining the rules here. So that's one rule. That's a multiplication division rule. The addition subtraction rule is a little weirder, but remember when I talked about significant figures, I talked not only about how many significant figures something has, but also the uncertainty. The addition subtraction rule has to do with uncertainty. So, fundamentally, you're looking for the least precise measurement again. You're looking for where the uncertainty is, the fewest decimal places. That's the wording your book uses. I have a problem with that, which I'll explain why. But if you look, this first number, the uncertainty is in the tenths place, right? And here, the uncertainty, and when I say uncertainty, remember, we're looking for the last significant figure. Whatever that last significant figure is, we're looking for that. So here it's in the, so there's the tenths, hundredths, we're in the thousandths, right? So whichever one is the least precise, the largest uncertainty, tenths are larger than thousandths, so we're going to round off our final answer again. This is what the calculator gives me. I'm going to round off to the tenths place after here. So we get 18.7. And past me agrees that it is 18.7. So there we go. Okay, now some of you may have jumped ahead to the next real point and the next kind of big question, which is, well, what happens if I've gotten both multiplication, division, and addition subtraction? Now, in my haste to get through them, I think I wanted to make sure that you understood that these 2 rules are for different operations. This rule is for when you have multiplication division. Sorry, I'm jumping around a lot here. This one is for multiplication division, is the significant figure rule. For addition subtraction is the uncertainty rule, right? And I also forgot to do this other thing. As promised, I'll explain why I frame it in terms of uncertainty instead of as decimal places like your book does. Imagine you have these 2 numbers that you're adding together. Right? And you say, oh, well, my calculator says that's 1530, right? Well, here, now, this is addition, so we're looking at, quote, decimal places, but there's no decimal points, so there's not really any decimal places. I like to frame it in terms of uncertainty. We look for the last significant figure in this number over here, which is the hundreds, right? And then over here, the uncertainty, the last significant figure. Remember, no decimal place means these trailing zeros are not significant. So no decimal means not significant, last significant figure. Here, no decimal, not significant, last significant figure is in the tens place. Well, what's larger? What's a larger uncertainty, hundreds or tens? The answer is hundreds. So we round to the hundreds place, so 1500. So that's why I like framing it that way better. Though it may be maybe more confusing, but it's more accurate. So if we ever encounter both at the same time, like in this problem, you deal with each one in order. So remember from math, parentheses, exponents, multiplication, division, addition, subtraction, right? So we deal with each step in order. So we have parentheses, so the first thing we're going to do is we're going to deal with addition, right? And the addition rule is going to take precedence first. So I'm going to end up with 23.77 times whatever this ends up being when we add these all together. So when we do this, we get, the calculator spits out 10.551. But we need to actually figure out where it would round. So if we look at our three numbers involved, think about which one has the largest uncertainty. The answer is this one. This is the largest uncertainty, has the fewest decimal places. The uncertainty here is in the tenths, here's in the hundredths, here's in the thousandths. So we're going to go with the tenths place. So we would round up to the tenths place, 10.6. There's a problem, though. I don't actually want to round it off, though. Because if I round off multiple times in a row, I create multiple errors. We only want to round once. So what I'm going to do is I'm going to mark where I would round it. So I'm kind of doing two things at the same time. It's like I'm rounding it. I'm not really rounding it, though. But this is going to dictate this number now, for all intents and purposes, has uncertainty in the tenths and only 3 significant figures. We're going to keep these for the calculator, but they don't really count anymore. So 23, I screwed that up, 23.77 times 10.551, right? Calculator answer is 250.79727. So we have to figure out where we'd round. Now this last step, we just did multiplication, so now we use the multiplication rule, which is what? Significant figures. This number has 4 significant figures. This number, even though it looks like it has 5, remember, because of the rounding up here, it's only really got 3. So we end up with 3 significant figures down here at the bottom, rounding off to 251. Now, I'm not going to be a huge stickler about this. I am going to be a stickler in that you need to end up with the right number of significant figures. But if you were to say round this, for the purposes of this class, if you gave me 10.6, and you gave me the answer that came out of that, which is slightly different, it's 251.962, and rounding up to 3 significant figures would actually give us 252. So you see how there's a slight difference there? I would accept that for the purposes of this class. I only express this so that you would know what is correct. The real thing I want to point out to you is you have to do the rounding on each step, each type of operation. So if you can do 5 addition steps altogether and just round them all as 1. You can do 5 multiplication and division all together and round them all as 1. But when you mix them, you've got to do the addition, round it, multiplication, round it. And you have to do each according to the proper rule of that step. Rounding, I think we all probably remember rounding rules. I'm not going to worry about rule number 3. Remember, if you're rounding a number like 10.676 and you're rounding off here, if this number to be dropped is 5 or greater, you round up, so it'd be 10.8. But if instead you were rounding 10.72 and you're rounding off to here, it'd be 10.7. You just round down. Okay, I want you to try these, and then I will show up with the answer. Okay, so for this first one, the calculator kicks out. It's possible. Be aware that it's possible that I might make mistakes on these. I might fat finger my calculator or something, so be aware that I may have an incorrect answer. But the rounding should be by the proper rules. So here's what my calculator spit out. So now I'm looking at this is multiplication, so we're looking at number of significant figures. This one has 2 significant figures. This one has how many? 2 significant figures, because these 2 zeros are not significant because there's no decimal point. This one has 4 significant figures. So my answer should have how many significant figures? It should just have 2. This should just be 14. Down here. Now we can do all of these together. These are all of the same type, multiplication and division. We can do them all together. I get 265.77753. My first 7 didn't go. There we go. Now, how many significant figures should we round to? This one has 3 significant figures, 3 and 5. So we go to the least. It should be 3 significant figures for 266. Down here, your calculator answer is 2.26352. Again, 3 significant figures, because they all have 3 significant figures, so that's the fewest. Okay, next. This is all addition and subtraction. I'm going to pause it, and I'm going to put all the numbers up on the screen, and then we'll talk about rounding it. Okay, here are my calculator answers. In each of these cases, I'm looking for what has the greatest uncertainty. So this one, if we look, this one goes out 3 decimal places to the... So when they're all decimal places, it's really easy. We just count out the fewest. This one only goes out 3. This one goes out 4. This one goes out 5. So 3 at the thousandths, that's where we want to round, because it's the least precise, right? This number goes out to more decimal places. This one goes out more. So we have to round to the least precise. So we round out 3 decimal places here. Now notice something interesting. This number ends up with, this is why number of significant figures isn't used. It's a different rule. We end up with a different number of significant figures than any of these have. So that's why you need to keep these 2 separate rules separate. So here I get this number. Again, we're going to do the same thing. They all have decimal places. This only goes out tenths, hundredths. Oh, no, sorry, tenths, thousandths, hundredths. Again, but still the tenths, we round to the tenths place because that's the largest uncertainty. Here, thousandths, hundredths, 10,000ths, right? Hundredths is going to be the largest uncertainty, so we round off to 4.67. And finally, 3.111, so this goes out to the thousandths, this goes out to the hundredths, we round off to the hundredths. Okay? So, the rounding rules tell you how to round. The significant figures and calculations rules tell you where to round. Okay, these are the tricky ones. Now that I think about it, I think I'm actually going to hold these over and just deal with these in class. Possibly. I don't want to make the video. No, I will. I'll go ahead and I'll make the video long. You can stop watching if you want. But what I'm going to do is I will so I'm going to show you the process on these. So this first one, right? First thing I need to do is do the subtraction. So the subtraction will be 568.99 minus 0.1. So that's going to be 336.89 is what I got. That's what this equals, right? So this is going to be all over 5.3. Now we have to round first, right? We still have to round first. So this number up here, we're going to round according to which rule? That's right. It's going to be the addition-subtraction rule. We're looking at uncertainty. This number goes out to the hundredths, tenths, so we round to the tenths. Although actually, to be totally proper, I'm going to demonstrate this. I'm not actually going to round. I'm just going to take note that this number truly only has 4 significant figures. So when we do the last step, we do this number divided by 5.3, and we get a final answer of 63.564, blah, blah, blah. It goes on and on and on and on. Now, I'm going to round this last one according to the multiplication division rule. This number has 4 significant figures, right? This one only has 2 significant figures, so I round to 2 significant figures. There's my final answer. Finally, I'm going to do this next one. Not finally. Actually, yeah, I will stop with the second one here. I will do the first operation here. Okay, so you'll notice this first number here, that is the product here, right? When I multiply these 2 together, that's what I get. So we have to round according to the multiplication rule, which is number of significant figures. This number has 1, 2, 3, 4, 5, 6 significant figures. This one only has 3. This number should be rounded to 3 significant figures. These are the only significant ones in this number. I'm going to keep this in my calculator, but for purposes of figuring out number of significant figures, only 3. Now, my last step, I add these two together, and I get this number. So, now I round the final number according to the last operation I did, which is addition, right? So we're looking at uncertainty, not number of significant figures. This number, having been rounded off here, its uncertainty is actually in the ones place. Here, this goes way out past the ones place. It goes out to the hundredths place. The hundredths place. So we round to the one that has the largest uncertainty. We round off to the ones place. So my final answer is rounded off here.